Hi, my name is Heitor Medeiros, and today I'm going to present our work WiSE-OD, Benchmarking Robustness in Infrared Object Detection, that was accepted at WACV 2026, and it was done in collaboration with Atif, Messi, Professor Eric Granger, and Professor Marco Pedersoli at ETS Montreal, in partnership with Distech Controls. Infrared object detection is a key for low-light applications, but fine-tuning from RGB to IR often hurts robustness under corruption domain shifts. So, we introduced the LLVIP-C and FLIR-C benchmarks, the first corruption benchmarks for cross-modality infrared object detection. Additionally, we propose the WiSE-OD, a training-free weight space ensemble that improves the IR robustness with no additional inference time cost. Hendricks and Dietrich proposed diverse corruptions for robustness in image classification, resulting in ImageNet-C and CFAR10C. Michaelis extended this work from classification to object detection, proposing the Pascal-C, Coco-C, and Cityscape-C, with a study of corruption and severity for different detectors' performance. In our work, we construct the IR benchmarks LLVIP-C and FLIR-C using the LLVP original dataset and FLIR original dataset, and expand these datasets with the different corruptions that were introduced by Dieter and Hendricks. And we also propose to use natural shifts from M3FD dataset, and we report the average performance on these shifts. We also benchmark different approaches to improve the robustness, and we measure this performance against the zero-shot performance, the linear probe performance with the fine-tuning, and the WiSE-OD as baselines. Our proposed method, WiSE-OD, starts from a pre-trained RGB model. Then we fine-tune the pre-trained RGB model using the IR data that is from the target dataset, for example, LLVP or FLIR dataset. And then with these infrared weights, we can perform interpolation of the weights, and we interpolate these weights and have the final WiSE-OD weights, and we can perform the final inference using the merged weights. Here we can see that WiSE-OD is a simple strategy that is used on the weight space of the pre-trained RGB model and the infrared fine-tuned model, and we combine this weight in a way that improves the robustness performance in our benchmark, and we can see that we have like several improvements on the LLVIP-C and the FLIR-C for the faster RCNN, the FCOS, and the RetinaNet that are classical object detectors. Also in real shifts, we measure the performance of a model that was fine-tuned on daily infrared image, and we measure the out of distribution with rainy infrared image, night infrared image, fog, and indoor. And we also perform the average of these corruptions real shifts that we have. And we measure against different detectors. And we can see that for the 4 detectors, we have like really good improvements on this performance. Here we can see the qualitative results of our approach against the zero-shot and fine-tune method. And we can see that there are some improvements on the box that we have compared with the fine-tuning. And we can detect over the out-of-distribution data. Similar effect occurs in the real shift. So for out-of-distribution data, our detections improve over the fine-tune method. To conclude, WiSE-OD consistently improves the robustness across the synthetic corruptions and real-world shifts in IR while preserving the in-domain accuracy. The method is simple and practical and requires no additional training compared to fine-tuning parameters or infrared overhead. Our benchmark and results highlight the need for robustness-aware infrared evaluation and provide a strong baseline for future works. Here you can have the access to our paper and our code, and see you in WACV. Thank you.